A spacecraft the size of a grand piano just woke up in the most remote region our species has ever reached, traveling so far beyond Pluto that the Sun appears as nothing more than an exceptionally bright star, and the data it is sending back from that extraordinary distance is challenging assumptions scientists have held about the outer solar system for decades. NASA's New Horizons spacecraft completed its historic flyby of Pluto on July 14, 2015, delivering images of a world that stunned the entire scientific community with its geological complexity and apparent ongoing activity. But Pluto was never the final destination of New Horizons. It was the primary target of a mission designed from the beginning to continue traveling outward through the Kuiper belt, the vast ring of icy objects, dwarf planets, and primitive bodies that orbits the Sun beyond Neptune, to explore the most ancient and preserved remnants of planetary formation in existence. Since the Pluto encounter, New Horizons has been traveling deeper into the Kuiper belt at approximately 14 kilometers per second, covering nearly 1.6 billion kilometers every year, and it has been doing so largely in hibernation mode. NASA's Mission Operations Team periodically puts the spacecraft into a low-power sleep state to conserve propellant, reduce wear on electronic systems, and extend the operational life of its nuclear-powered gamma-ray spectrometer and other instruments. The spacecraft wakes from hibernation in response to commands transmitted from Earth's Deep Space Network, a global array of massive radio antennae located in California, Spain, and Australia, which maintains communication with New Horizons across the most extraordinary distance any operational spacecraft has ever maintained contact with Earth. The communication challenge itself deserves understanding, because it illustrates how far New Horizons has genuinely traveled. Radio signals traveling at the speed of light, 300,000 kilometers per second, require approximately 8 hours to travel from New Horizons to Earth when the spacecraft is at its current distance. That means every command sent from Mission Control in Maryland takes 8 hours to arrive at the spacecraft, and every response confirming receipt takes another 8 hours to return. Mission operators plan spacecraft activities months in advance, uploading complete sequences of instructions that New Horizons executes autonomously without requiring real-time control. A mission operating on 16-hour round-trip communication delays cannot be flown by remote control. It must be trusted to operate with extraordinary autonomy. After the Pluto flyby, NASA selected a secondary Kuiper belt object as New Horizons' next target, a body formerly designated 486958 Arrokoth, located approximately 6.4 billion kilometers from Earth. On January 1, 2019, New Horizons conducted the most distant successful flyby in the history of space exploration, passing just 3,500 kilometers from Arrokoth's surface at a velocity of approximately 51,500 kilometers per hour. The images it returned showed a unique contact binary, two spherical lobes fused together gently enough that neither disrupted the other, providing direct evidence that the earliest building blocks of the solar system assembled through slow gravitational accumulation rather than violent collisions. What Arrokoth revealed about the chemistry of the outer solar system may ultimately prove as scientifically significant as its structure. Spectroscopic data from the flyby suggested the presence of organic molecules and methanol ice on Arrokoth's surface, complex carbon chemistry preserved in the deep freeze of the outer Kuiper belt since the solar system formed 4.6 billion years ago. These findings contribute to the growing scientific argument that the chemical building blocks of life were present in the outer solar system from its earliest days and were routinely delivered to the inner planets, including Earth, through comet and asteroid impacts over billions of years. New Horizons has continued traveling since the Arrokoth encounter. Mission scientists have been using the spacecraft's long-range reconnaissance imager, LORI camera, to identify and photograph additional Kuiper belt objects along its trajectory, gathering data on objects too distant for detailed ground-based observation. The spacecraft's ultraviolet spectrometer, ALICE, has been used to study the hydrogen and helium environment of the outer heliosphere, mapping the boundaries of the Sun's influence as the solar wind encounters the interstellar medium. The power source that makes all of this possible is a radioisotope thermoelectric generator, an RTG containing plutonium-238 that generates approximately 245 watts of electrical power continuously through the natural radioactive decay of its fuel and the conversion of that decay heat into electricity. This is the only power source capable of operating a spacecraft at distances where sunlight is too weak to power solar panels. By the time New Horizons reached the Kuiper belt, sunlight arriving at the spacecraft was only approximately 1,000th as intense as it is at Earth's distance. The hibernation cycles that New Horizons undergoes between active science periods are not passive rest. Even in reduced power mode, the spacecraft's most critical systems continue operating. The computers monitoring spacecraft health, the RTG continuing its power generation, and the communication systems listening for commands from Earth. When a wake-up command arrives after 8 hours of travel, a carefully choreographed sequence begins. Instruments powering up, thermal systems restoring operating temperatures, the high-gain antenna orienting precisely toward Earth to begin transmitting the data accumulated during the hibernation period. NASA's mission team formally plans New Horizons operations in annual review cycles, with each wake-up and science campaign approved based on the spacecraft's remaining instrument performance and the scientific value of available targets. As of current planning, New Horizons is expected to continue productive science operations into the 2030s, conducting remote observations of additional Kuiper belt objects and heliosphere studies as it continues its outward trajectory through the most distant human-made exploration zone in existence. The spacecraft carries a symbolic payload that reflects the human hopes embedded in its mission. Attached to New Horizons is a small amount of the cremated remains of Clyde Tombaugh, the American astronomer who discovered Pluto in 1930. As New Horizons travels beyond Pluto and deeper into the Kuiper belt, it carries the man who first found that world with it, past the planet he identified through years of painstaking photographic comparison in the Arizona desert, past the icy remnant Arrokoth at the edge of the outer solar system, and eventually toward the boundary of the sun's gravitational influence. The most distant operational spacecraft in human history just woke up, looked back at a sun barely brighter than the brightest stars, and transmitted its data across 8 hours of empty space to a team of scientists in Maryland who are aging alongside it. So here's the question that I want you to sit with and answer in the comments. As New Horizons continues traveling further into the Kuiper belt and eventually beyond the heliosphere's boundary into true interstellar space, do you think humanity will ever build another spacecraft capable of reaching and surpassing it? Or is New Horizons effectively the permanent record holder for the farthest human exploration in our lifetime? Follow this page right now, because the most remote exploration mission ever conducted continues operating every single day, and every time it wakes up we get a little closer to understanding what the edge of our solar system actually looks like.